Today we're going to look at some advanced limit setting options available in SoundCheck. Let's open up the limits editor. This is where you set pass or fail limits for your measurements. The data tab is where you enter your upper and lower limits, and the specific data that the limits are to be applied to. In the parameters tab, you can set your method for aligning limits, and you can read about all of these options in the manual. So I'm not going to review that now. Instead, I'm going to focus on the advanced parameter options. There's some really useful functionality in there. We'll just click on this Advanced View checkbox here, and we get some additional useful controls. The Absolute Comparison Precision field lets us set the number of decimal places for the limits, which affects the pass-fail margins. For example, say I have a curve with a limit of 80 dB set at 13.2 kHz. If my data precision is set to 2, it sees my measurement to 2 decimal places, and we can see it's 80.18 dB, which exceeds my 80 dB limit, and it fails. If I now change that data precision to 0, that's no decimal places, my 80.18 dB reading is now rounded down to 80 dB, which is right on the limit, so it passes. This gives you very tight control over your pass and fail limits. The mapping section controls linear versus log, as well as floating limits in X. This setting determines the interpolation of the data to the limit curves if it is linearly or log-spaced. In this example, I have a curve with an upper limit on. I expect the result to pass, but it does not. Let us find out why. We'll use a neat feature called Output Failed Point Curves. When you enable this, it generates additional curves showing exactly the points that failed in comparison to the upper and lower limits. You can also view these failed points in a table to see precise numerical values, and we see that the failed point was at 125 Hz. Looking back in the limit step, we see that 125 Hz has a value of 1.370%, and if we use simple linear math, the upper limit at 125 Hz is 1.375%. So, why didn't the limit step pass? This is because we are making linear calculations of the upper limit, but the limit interpolates on a logarithmic scale as the x-axis displays the frequency domain, which is normally shown logarithmically. If we switch the mapping option to linear, the data is below the upper limit, and it passes. Let's just zoom in and take a closer look. Float limits in X allows limits to float back and forth along the x-axis for the best fit. This is useful if you're applying limits to curves with sharp peaks and dips, due to reflections, for example. You also have control of the step size increments and the maximum and minimum percentages that the limits can float. For example, I have a curve with a peak, and I'd like the shape of the limit curve to match the shape of this peak, but apply it at the frequency where my new peak is. I'll switch to my new curve, and when I apply the floating limit, it shifts to best fit the new curve peak. Notice that only the x-axis has changed and the y-axis remains the same. I hope you found this demo of advanced limit setting features useful. Please check the SoundCheck manual for further details.